So what we're going to do is we're going to use Tinkercad to make these gear sets, and we're only going to use 3 primitives that are already available in Tinkercad to do it. We're going to make a spur gear with a rack to go with it, then a helical gear and a helical rack, and then finally a herringbone gear with a herringbone rack, although we will cover helical bevel gears. We're going to use that to make this. What this does is takes rotary motion and changes it into linear motion. So the input is through this cream gear here. Then it feeds through the cream cam in the front, which operates that blue gear, and that will slide this backwards and forwards. So it's only really made of 7 parts. The first bit is the gear that wobbles backwards and forwards. Then we have the rack that does the in and out motion, the cam that changes the rotary to the rock backwards and forwards. There's a little faceplate there to hold the rack in place, then a clip to hold the gears in place. And finally, we have the actual input gear and the base. I will, of course, make these parts available in Thingiverse for anybody who wants to print it off. You print those off, put them all together, and this is what you get. Now, if I rotate that back gear, then that front gear wobbles backwards and forwards, pushing the rack backwards and forwards. So we start with the blank workspace. Go to here, which is the search shapes, click that and type in gear. This will pull up all the gears that's available to you in Tinkercad, and we want this one, which is so-called metric gear. Pull it onto the work plane. We'll make this a height of 4 millimeters, and you'll notice here we've got some things we can change. I absolutely hate that color because you can't see it, so we'll change that color so that we've got a nice cream color. And here we can set the teeth. For no particular reason, I'm going to set that at 25. And here is the actual tooth size, which is default module 1. I like module 2 because it's nice and chunky, and it means it's going to wear a bit better. Once we've done that, we can close this and create a center hole to take our axle. So pull down the circular hole, set the side 64 so it's nice and smooth, and we're going to change that to 6 millimeters. So we've got a 6 millimeter hole to take an axle. Highlight both of them and then use the align tool, which is here, to highlight it to the center of the gear. Once we've highlighted it to the center of the gear, we can then group them by clicking the group button, and we will have created our spur gear. Let's put that to one side. What we need now is the rack, and that is actually a primitive available. So back to search shapes, and this time try Crema. It's something weird like Kremler or something like that, but Crema pulls up that particular primitive, and we can drop that on the workspace. Again, we can rotate that round and then drop it to the workspace by pressing D, and we have our rack. You'll notice here there's an awful lot of things we can change. In this case, all we really need to change is the module to match the module of the gear that we just made. Now, if we realign that gear, so we twist it round, set it to D so it's on the plane, move it there, and then we can align both of those two by highlighting the two of them and hitting the align tool onto the rack. And we've created our spur gear rack and pinion. To create a helical gear and a helical bevel gear, let's just move the spur gear out of the way for a moment and go back to the search shapes. Type in Pro Gear. And it will pull up what it calls the Pro Gear. Drag and drop that onto the workspace, and you can see that we've got an awful lot more things that we can change. We're only going to highlight a couple of things at this time. Let's change the teeth to 25 so that it's the same that we have on the number of teeth on the spur gear. And for a moment, I'm going to put the height to 10 so that we can actually see something interesting. Let's copy that by hitting the copy key and move it out of the way. On this one, if we go down here, we'll see we've got 2 angles, bevel angle and helical angle. If we change bevel angle to 45, flip that over 180 degrees, and we can see we've created ourselves a nice bevel gear. Equally, if we go down there and look at helical angle and change that to 30, then what we get is a helical bevel gear. Let's just get rid of that because we're looking at a helical spur gear. Drag this back into its space there, go back down there, and we've got helical angle that will change to 30, and we'll get a helical gear. Now, of course, we want the rack to match it, so click on the rack, and if you have a look here, then we've got an awful lot of things that we can set here as well, including what it calls inclinatio. Clearly this was written by somebody in Spain, and if we change that to 30 degrees, what we get is a matching rack that will take that helical gear. We then line that up. Zoom in on it, we can see that we've got a helical rack that matches with the helical gear. To create a herringbone gear, all we really need to do is copy that and mirror it. So hit the copy key there, and then you'll see two triangles, which are the mirror key, and it gives you the direction you can mirror it. We mirror it in that direction. If then we'll grab one of those and pull it out, then we need to place these two exactly on each other. To do that, you take a work plane and put the work plane onto the face of one of the gears. It'll create a new work plane. Click on that and hit D, and it will drop it directly against the one that we just did. Grab another work plane and move it randomly somewhere else, and it will create the original work plane. Now we just need to make sure that those two are aligned to each other, so hit the Align key and then align them. And then just check the alignment. Now all we need to do is highlight the two of them and group them. Zoom in on it, and we can see we've got our herringbone gear. We do exactly the same thing with this one here. Just copy it, mirror it, move it out of the way, work plane. So it's on that surface there. Click on that one, hit D to drop it down, repeat the work plane into a random space, so we get that. Then we need to align it. Then we can highlight it and group it. And we have our herringbone rack. Okay, that's it. Now what we're going to do is create this. There are clearly lots of things to play around with, and I recommend you play around with them because that's really how you learn. And we're just going to take this spur gear rack and pinion to create this section here, and then the whole machine based around that section there. Okay, we're basically back to the beginning with the spur gear and rack that we made. If we click on the rack, we can see number of teeth is 10. That's the default setting. We want to change that to 14. It's also 10 millimeters thick, which again is the default setting, and I want it 4 millimeters thick. So we can click that and make that 4. Now it's lying point upwards, which is not very convenient. So we swivel that round to 90, press D to drop it on the work plane, and we get our rack in a convenient format. We need those two little holes at the end that we're going to use to attach it to other things later. And for that, just take a circle, smooth it out, change that to some reasonable size. I'm going to have a hole at 6 millimeters, and so 12 gives me plenty each side. If I then click a hole, drag that, smooth it, change that to 6, which is my bore size. Then I can align those two. And then by highlighting and grouping them, I get the hole shape that I want. If I copy that, then I'll get 2 of those that I can put either side of my rack to create the connection points that we saw. If I highlight one side and line that up, then I can line it to the center, which is nicely lined there, and then just move it to a position that I think is appropriate by using the arrow key. Notice the snap grid here is set at 1. We can move that by any size you want. Well, these sizes actually, so we can change the size every time we press the arrow key, how much that will move it by. If we zoom in there, then we can get a good view of what it's actually doing until we've moved it to some convenient position. If we then click back on here and jump out again, we can do exactly the same thing to the other side. Now if we highlight those two and group them, we get the little rack and pin, or the little rack with 2 pins at either side that we can connect it to something. Click home so we can see that and take our spur gear. Now our spur gear needs a slot cutting in it. Again, it's inconvenient like that, so let's swivel that round to 90 and press D to drop it to the work plane. What we really need is a yoke, and the yoke has to be a little bit bigger than the pin of the cam that's going to go through, which will be 6. So if we take that, which is a cube, and change that to 6.2, that gives it just a little bit of leeway so that it can move in and out using a pin at 6. And we need to know how long that's going to be. The cam I'm going to make has a circumference of 37 millimeters, and I'm going to put rounded ends on it, and those rounded ends are going to be made from this primitive here. So if we slide that primitive over, we need to reorient it so that it's standing up and standing in the right direction. So to stand it up, use this one. And then to reorient it, use this one here. And then we need that to be 6.2 or to match 6.2. So 6.2. And then the width to make it a semicircle is 3.1. Now if we make that a hole, then we'll be able to create our hole. Now this is 3.1, remember. It'll have another side at 3.1. We want 37 in total, so this needs to be 31. Now we can zoom in on here because it's all getting a bit too far away. We zoom in on here, and we can copy that, mirror it, and then once the right way around, we can drag it down to there. To line these two up, we use the same trick that we did before. Use the work plane, D key to drop that shape to that work plane. Again here, we use a work plane, D key to drop that to the work plane. And then we can line these up. If we now merge that, we have ourselves a hollow cutout. We need to create a surround for this hollow cutout, and to do that, we do exactly the same thing, but this time with solid shapes. Now remember, it's only 4 millimeters thick. This we want to be 2 millimeters or 3 millimeters either side. So it's 6 millimeters, we need that to be 12 millimeters. We then repeat this. When we've created these two sections, we can then align our cutout to our solid. And then we're aligned, we can group them. And we get our cutout. Now we want our cutout obviously to be in here. Ungroup and regroup. And there we go. We've made the little bit that's going to wobble around. Now that bottom bit is where the bottom pin of the cam will go. So it can go anywhere along there as long as it doesn't get too close to this, because remember, we're going to have an axle in there. So the bottom clip goes nicely in there. So that's two parts made. Let's move them out of the way. And to create the cam, it's pretty easy actually. We get a circle, smooth it out. We want it to be 4 millimeters high. And remember, I said with a diameter of 37 millimeters by 37 millimeters. Then we need a pin. So we grab another circle, smooth it out. Remember, the pin was 6 by 6. And with this is 4 high, the pin's got to go through that one there. So the pin needs to be at least 8 high. So 9 will stop it falling out, really. Line those two up by highlighting both of them. We want to line it to the center and the edge so that we get the cam like that. Now the cam needs just a little bit of leeway. So if we change that to 0.1 and just move it a couple of points up, that'll be a nice place for the cam. For the drive shaft of the cam, we use a hex. Change the hex size to 6.8 because we're going to make the driver 7. So we do this as 6.8, 6.8. Then because of tolerances, we'll be able to actually shove the thing through. Make that a hole and center that to your cam. And this will be the cam driver. Then group the whole lot. We have our cam. Shove that to one side. Okay, to make the drive cog, we need to save ourselves some work. So this one, copy it, drag it to one side, ungroup it, delete these two. We have basically our drive cog. Of course, it needs an axle, so ungroup it. Now this is 6. We want it a bit bigger because remember we made this 6.8, so we're looking at 7. But if we make that 8, then we'll have plenty of leeway. So 8, 8. Turn it to a solid. It needs to be 4 to go through here, 4 to go through the support plate, and a little bit of extra. So let's call that 8.5. And then we need to center it. Now, if you remember, we made that at 6.8. So we need to grab a hex and make the hex 6.4. This, remember, is 8.5 up, so 8.5 off the base plate. And this has only got to go through 4 millimeters, so 4 millimeters for that. And then align all of this. Group the whole thing. And that's our drive gear. Now we've done that, we need to align a few things. So let's take this, and this sits at the bottommost. Next we take this, and remember we put this to be 8.5 above, so type in 8.5 so that it sits above this. Then we can align those two. Now it sits beautifully where it needs to be. We are going to put a base plate in here, and what we're doing is creating indexing holes. So if you remember, the size of this one was 8. So take a hole, make it smooth, and we need to make that 8 by 8. And then we can align it to the center. Make that a little bit taller so you can grab it. And then we have a place where we're going to know where that axle needs to be. Then we grab this one, and this will sit on topmost. So this is 8.5 plus 4, so it's 12.5 from the top, from the base rather. And that's where it's going to sit. And it needs to be aligned to the center of this. So press the Shift key, hit that, and it will align two objects. Align them, and we just need to align it to the center there, because we're going to move that up to be the right position. You see the snap grid is set at 1, so if I highlight that, then it'll move relatively quickly across that pin. Now if I zoom in on there, we can see it's gone too far. So if we click that and set the snap grid to 0.1, then we can move it back a little bit until we've got a bit of leeway. There we go. It's about 0.2 millimeters leeway. And that's where the second one axle is going to be, right there. So we can take another axle, but remember this one was 6 millimeters. And we can align it to the center of here. It'll be a bit difficult to get it right into the center. So what we do is unmerge that. And now we can align these two together, make this bigger so it sticks out. Shift, click that, align, and align to the center of there. There we go. Once that's aligned, we can re-merge this. So you click on the object you want to merge, hold down the Shift key, click on the next one, keeping the Shift key held down, click on the third one, and then we can group them. And there we go. Now we can move everything out of the way. It might have seemed a bit dumb to do it that way, but it makes sure that everything has got a registration point where it can align to. So if we then take a bar of some kind, and we'll make that 4 high, by say 16, by 45, and if we put those there, there we go. Make sure that they're aligned. We can then merge that. And as long as these fit in those two holes, your base plate can be any shape you want. I made a pretty base plate with semicircles, but I made sure that those holes were in the right place using that technique. So of course you may want to use this in something else, so whatever base plate you want to design, as long as you keep those indexing holes at the point of where you put the axle. When you slot everything together, it's going to work, so just print it off, slot it together, and it'll work just fine. What we'd use it for? Well, every time that does one full rotation, of course, that goes in and out once, so a counter of RPMs would be quite cool. But I have done a previous video on how to make clips, so I didn't cover that in this video, but I did want to go a bit more in depth because, you know, there's some interesting techniques and some interesting bits and pieces in Tinkercad you may not have been aware that is actually there just for you to use. Now, I will of course put these files, as I said, on the Thingiverse should anybody just want the model. I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.